So today we will see develop an app with Vertex AI Gemini 1.0 Pro. Let's see the overview. Gemini is a family of generative AI model that is designed for multimodal use cases. It comes in three sizes, that is Ultra, Pro and Nano. Gemini 1.0 Pro is available for developers and enterprise to build for your own use cases. Gemini 1.0 Pro accepts text as input and generate text as output. There is also a dedicated Gemini 1.0 Pro Vision multimodal endpoint that accepts text and imaginary as output and generate text as a output. SDKs are available to help you build apps in Python, Android, Node.js, Swift and JavaScript. On Google Cloud, Vertex AI Gemini API provides a unified interface for interacting with Gemini models. The API supports multimodal prompts as input and output text or code. There are currently two models available in Gemini API. First is Gemini 1.0 Pro model that is designed to handle natural language tasks, multi-turn text and code chat and code generation. Gemini 1.0 Pro Vision model that supports multimodal prompts. You can include text, image and video in your prompt request and get text or code responses. Now let's see what is Vertex AI. So Vertex AI is a machine learning platform that lets you train and deploy ML models and AI application and customize large language model for you in your AI powered application. Vertex AI allows for customization of Gemini with full data control and benefits from additional Google Cloud feature for enterprise security, safety, privacy and data governance and compliance. To learn more about Vertex AI, view the link in the next steps section at the end of the lab. So in this lab, we will learn Vertex AI SDK for Python to call Vertex AI Gemini API. Now let's see the objective. So in this lab, we will learn how to perform the following task. So first of all, we will develop a Python app using Streamlit framework. Install the Vertex AI SDK for Python. Develop code to interact with the Gemini 1.0 Pro model using the Vertex AI Gemini API. Develop code to interact with the Gemini 1.0 Pro Vision model using the Vertex AI Gemini API. Customize your application and deploy and test it on Cloud Run. Now we will set up the lab. So for setup, we will click on the Start Lab. Now click on Open Google Cloud Console. It will automatically enter the username. Click on Next. Now we will enter the password. Click on Next. Click on I understand. Agree the terms and condition. Now we will activate the Cloud Shell. Click on Continue. We'll check the active account name using this command. Click on Authorize. So this is our active account. Now we will check the project ID using this command. So this is our project ID. Task 1, configure your environment and project. So for this you need to sign in to Google Cloud Console with the lab credential and open Cloud Shell terminal window. So we already sign in and we open the Cloud Shell terminal. Now next we will set up the project ID and region environment variable in Cloud Shell. For this we need to execute this command. So setup is done. Next, in order to use various Google Cloud services in this lab, we need to enable few of the APIs. So now we will enable the API. So APIs are enabled. We will check our progress. It's completed. Next task is set up the application environment. So in this task we will set up Python virtual environment and install the application dependencies. Confirm that Cloud Shell is authorized. So we will use this command to confirm that our Cloud Shell is authorized. Okay, so our Cloud Shell is authorized. Next, create the app directory. So to create the app directory we will run the following command. Okay, so mkdir is used for creating the directory. So we will create the directory and will give the name as Gemini Gemini-app. Next, change to Gemini-app directory. So we will use change directory. Okay, to change to Gemini-app. So now we will in Gemini-app directory. Now set up Python virtual environment. Create a virtual environment on the top of the existing Python installation so that any packages installed in this environment are isolated from the packages in the base environment. When used from within a virtual environment, installation tools such as pip will install Python packages into the virtual environment. So for this, to create the Python virtual environment from within the Gemini-app folder, we will run the following command. Okay, let me maximize this little bit more. Okay, now we will activate the Python virtual environment. So activation is done. Next, install application dependencies. A Python requirement file is a simple text file that lists the dependencies required by your project. To start, there are 3 modules we need in our requirement file. Our app is written using Streamlit, that is an open source Python library that is used to create web apps for machine learning and data science. The app uses Vertex AI SDK for Python library to interact with Gemini API models. Cloud logging is used to log information from our application. So to create the requirement file, we will run the following command. Okay, it's done. Next, we will install the application dependencies using this command. dependencies are installed. Next task is develop the app. The app source code will be written in multiple .py source files. Let's start with the main entry point in app.py. Write the main app entry point. To create the app.py entry point code, run the following command. Okay, it's done. Now we will view the content of the app.py file. So this is the content of the file. The app uses Streamlit to create a number of tabs in the UI. In the initial version of the app, we build the first tab story that contain functionality to generate a story, and then incrementally build the other tab in subsequent tasks in the lab. The app first initializes the Vertex AI SDK, passing in the values of the project ID, region, environment variable. It then loads the Gemini Pro Vision model using the generative model class that represent a Gemini model. This class includes method to help generate content from text, images and video. The app creates 4 tabs in the UI named Story, Marketing Campaign, Image Playground and Video Playground. The app code then invoke the render underscore tab1 function to create the UI for the story tab in the app's UI. Now we will develop tab1 story. To write the code that render the story tab in the app's UI, we will run the following command. Now we will view the content of the app underscore tab1.py file. So in the above code, the render underscore story underscore tab function generates the UI control in the tab by invoking function to render the text input field and other option. The generate prompt function generates the text prompt that is supplied to Gemini API. The prompt string is created by concatenating user entered value in the tab UI for the character of the story, and options such as story length, either it's short, long, creativity level, high, low, and story premise. The function also return a temperature value based on the selected creativity level of the story. This value is supplied as the temperature configuration parameter to the model, which control the randomness of the model's prediction. The max output token configuration parameter specifies the maximum number of output token to generate per message. To generate the model response, a button is created in the tab UI. When the button is clicked, the get underscore Gemini underscore pro underscore text underscore response function is invoked, which we will code in the next step in the lab. So next we will develop response utils. Okay, so the response utils.py file contain function to create model responses. Now we will view the content of the response utils file. Okay. So in the above file, the get Gemini Pro text response function uses generative model and some of the other classes from the Vertex AI preview generative model package in the Vertex AI SDK for Python. From the generate content method of the class, a response is generated using the text prompt that is passed to the method. A safety setting object is also passed to this method to control the model response by blocking unsafe content. The sample code in this lab uses safety setting value that instruct the model to always return content regardless of the probability of the content being unsafe. You can access the content generated and then adjust this setting if your application require more restrictive configuration. So to do this, you can go to safety setting documentation. Next task is run and test the app locally. So in this task, we will run the app locally using Streamlit and test the app functionality. So to run the app, we will execute this command in the Cloud Shell. Okay, so our app is available locally. Now we will access it. Okay, awesome. This is our application. It's showing 4 tabs. First of all, story, market campaigning, image playground, and video playground. So in story, it's given us option to generate a story by entering character name, what type of character it is, what personality does the character have, and where does the character live. Then we can select the length of the story as short or long. Then what is the story premise, uh, that what it suggests. Okay, then select the creativity level, that is high or low. And then once all the field we fill, then click on generate my story. Then next is market campaigning. Okay, as of now it's not developed. Okay, then image playground and video playground. Now we will test the story tab. Generate a story by providing your input, view the prompt and view the response generated by Gemini 1.0 Pro model. So to generate a story in the story tab, leave the default setting and then click generate my story. Okay, so we will leave this setting as it is and click on generate my story. It's generating the response using Gemini. Okay, awesome. So this is our story response. Okay, so a response is generated. Okay, we can view the response in the story response tab. Next, to view the prompt that used to generate the response, click the prompt tab. Okay, okay, so this prompt we provided. Okay, okay, so let's check the progress. Awesome, it's completed. Okay, so now we will stop our application by using Control C. Okay, so we are done with the story tab. Now we will generate a marketing campaigning. Okay, so we are done with the story tab development and deployment. Now we will work on the generate a marketing campaigning tab. Okay, so in this task we will use Gemini 1.0 Pro text model to generate a marketing campaigning for a company. You develop the code that generate a second tab in your app. Okay, so here we are developing the second tab, that is marketing campaigning. Okay, so develop tab second, marketing campaigning. To write the code that rendered the marketing campaigning tab in the app UI, run the following command. Okay, we stop this. Now we will modify the main app entry point. Okay, so for this we will execute this command. Now test the app marketing campaigning tab. Generate a marketing campaigning by providing your input. View the prompt and view the response generated by Gemini 1.0 Pro model. So we will do this by executing this command. Okay, it's up now. We will check this. Okay, now we will go to marketing campaigning. Okay, so see, this is our marketing campaigning application. Okay, so to generate a marketing campaigning, in the marketing campaigning tab, leave the default setting and then click on the generate campaigning. Okay, so here we are generating marketing campaigning. So we have provided the name of the products as Zoomzo, and the product category is clothing. uh, our target audience is in between the age of 18 to 24, and location is urban. So the goal of the marketing campaigning is increase brand and generate leads. And our brand voice is formal, and estimated budget is $1,000 to $5,000. Okay, and now we will click on generate campaigning. It's generating the response using Gemini. Okay, so awesome, it's generated the campaigning response. Okay, so this is our marketing campaigning. Okay, and the prompt provided is this. Okay, so awesome, it's generating awesome marketing campaigning. Okay, so now we will check our progress. Okay, it's completed. We will stop this using Ctrl C. It's stop. Let's close this.